Hey everybody, Dr. Nelson here. This is a video lesson about combinations. So what's going to happen is for the first couple of pages you can take notes with me, and then you have a chance to pause the video and try a problem on your own, and then at the end you can see how you did. Alright, so what exactly is a combination? Well, a combination is a grouping of objects in which the order is not important. Okay, let's write that down. So it's a grouping of objects in which the order is not important. All right, and the key word here is not. All right, so once again, a combination is a grouping of objects in which the order is not important. So let me give you an example. Let's say you go to a restaurant and you want to order 3 items off the menu, right? And let's say you tell the waiter or waitress you want the taco, you want a Coke, and you want some fries. All right, doesn't that sound good? All right, but how about this? Say if you told the same waiter that you wanted a Coke, a taco, and some fries. Do you see how these two things are actually exactly the exact same thing? Okay, so the order doesn't really matter. You're still getting the same 3 items. So that's what a combination is when the order, okay, is not important. And there's this thing you gotta know called the combination formula. Right? And what it allows you to do is it allows you to determine a certain number of combinations when you're given a set size of a number of things, and then the number selected. So take a look, please, at this little expression right here. That's something you got to know and know well. All right. So anytime you see C, it means combination, and the n value, that's the size of the set. All right. So for example, there'd be 4 items in the set, and the k value is the number of items you're selecting. All right. So over here, my k value would have been 3 because I selected 3 different pieces of food from the menu, right, or drink as well. And over here, this shows you how to actually get, all right, the number of combinations. All right, so what you do is you create a fraction, and the numerator is the permutation of the n value. So in our case, the n value is 4. So it's going to be 4 factorial over, now notice we have parentheses, and in parentheses, it's the n value minus the k value factorial. So it's going to be 4 minus 2 factorial, and then times the k factorial, which is going to be 2 factorial. All right, so I ran out of room, so I'm going to continue over here. So 4 factorial really means 4 times 3 times 2 times 1 over, now 4 take away 2 is 2, right? So it's going to be 2 factorial, which is really 2 times 1. And then we have another 2 factorial, which is really 2 times 1. So now what I can do is I can reduce. So I can cross off common factor of 2, and I can reduce this with this and make that a 2. And what's left over is 2 times 3, which is 6. So there are 6 total combinations when you have 4 items and you pick 2. All right, so let's turn the page. All right, so let's take a look at this first problem here. So here we have, again, it's combination, and we have 6 items, and we're selecting groups of 3. So if I was going to write down the expression, it's going to be 6 factorial over 6 take away 3 factorial times 3 factorial. All right, so now I'm going to expand this over here. So 6 factorial means 6 times 5 times 4 times 3 times 2 times 1 all over. Well, 6 take away 3 is 3, so 3 factorial is 3 times 2 times 1. And then 3 factorial again is another 3 times 2 times 1. All right, so now we need to reduce. So I know that I can cross these and these off, right, because they're the same factor. And I know that 6 and 3 can be reduced to make that 2, right? And then I can cross off the 2 and the 2. So finally we have 5 times 4. So altogether there are 20 combinations. All right, let's do one more. So here the problem says, how many ways are there to choose 3 people to receive a prize out of 9, assuming that no one earns more than 1 prize? All right. So for this one, we need to set up our expression. So it's going to be 9 here and 3 here. Okay. And again, the 9 represents the total number of possibilities, right, or people, and 3 is the number of words you're giving out. So to set this up, it's now going to be 9 factorial all over. Well, 6 take away 3. 9 take away 3 is 6, right? So it's going to be 9 take away 3 factorial, but then times 3 factorial. All right, so now let's expand this. So it's going to be 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 all over. Well, let's see. Well, 9 take away 3 is 6, so it's going to be 6 factorial. So 6 times 5 times 4 times 3 times 2 times 1, but then also times 3 factorial. So times 3 times 2 times 1. So now let me cross off our common factors. We have a 3, 2, and 1 here. And we have a 6 and a 6 and a 5 and a 5 and a 4 and a 4. But then I can reduce the 9 and the 3, right? So that's a 1 and that's a 3. And then the 8 and the 2, that could be a 4. And that could be a 1. So let's see if there's anything else we can reduce. So now we have 3 times 4, which is 12, times 7, which is 84 on the top. And then all we have now on the bottom is just a 1. So altogether, there are 84 different ways that you could award the 3 awards to the 3 people at a time when you have 9 people altogether to choose from. All right, so now that you understand a little more about combinations, why don't you pause the video and try the Your Turn Now problems, and when you're done, hit play. You can see how you did. All right, good luck. All right, welcome back. Let's say I do these practice problems. So to save a little bit of time, I've already written out all the steps, and I've circled the answers. So the answer to the first problem was 35 combinations, and the answer to the second problem was 120 combinations. So if you got it right, great job. If not, take a look at try to see what you did wrong, and hopefully you understand it a little bit better after that. So the key thing you have to remember about combinations is this expression right here. Okay. If you understand how to use this, you really should be really in good shape when it comes to learning about this topic. All right, bye-bye.